Assalamualaikum and good evening. So today I would like to present about the technical report of vehicle dynamic. So we are from group 5 and these are our group members. Okay. So introduction. The main goal of a car suspension system is to keep its passenger comfortable, healthy and not tired while driving on a different type of road. On the other hand, passive suspension system make it hard to find a good balance between ride comfort and handling. A passive suspension system is made up of two main parts, a spring and a damper. No energy is added to the system. Because it needs power and from outside the car, an active suspension system is more complicated, more expensive and heavier than a regular suspension. Because of this, passive suspension systems are great for light electric vehicles because they are easy to use and don't cost much. So statistical model have to be made so that the comfort could be judged without having to build a specific prototype. Because the system is complicated, this method has its limits. Engineers can now use simulation tools to look at the vibration characteristics of structure and figure out which part of setting will work to solve the vibration problem. So problem statement, suspension system act as support to carry the vehicle weight and protect both the driver and passenger from vibration, and maintaining necessary contact between tires and road surface. If the suspension system does not fulfill the emission requirement, this suspension will certainly have a problem and eventually endangering the driver life. So the objective to set up the MATLAB and Arduino to compare the simulation model between the simulation model for quarter car wheel in MATLAB, simulate and expected result. Scope simulation model will build in MATLAB, Simulink and Arduino. So that's all for me. Thank you.
Hi and Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Shafi Dibawan Fazi. So now we present about the teacher review for this project. The first one is the full car model. What is full car model? Full car model is the full vehicle model that consists of the car body connected by the suspension system to four wheel. This figure show about full vehicle model free body diagram. Each wheel is modeled as linear spring, and each active suspension system is modeled as a linear viscous damper, a linear spring, and force actuator. The car body is free to have pitch and roll, and the wheels are free to bounce vertically with respect to the car body. This formula for full car model, the first equation is about yaw motion, and second one is pitch and roll equation. Then about half car model. Half car model is defined as two wheel, rear or front wheel, which has four doors. Its tire can be modeled as a single spring or spring damper subsystem. The spring rate damper coefficient can be modeled with linear equation like this equation. The vehicle body has pitch and bounce degrees of freedom. They are present in the model by four states. There is vertical displacement, vertical velocity, pitch angular displacement, and pitch angular velocity. Quarter car model. Quarter car model is the simplest representation of a vehicle that belongs to Lames vehicle models. It is widely used in the vehicle and suspension analysis, particularly those related to the ride dynamics. It is used to investigate the vibration response of car with uncertainty under random road input. The Sprung mass, unsprung mass, suspension damping, suspension stiffness, and tire stiffness are considered as random variable. The road irregularity is considered as a random process and modeled by means of a simple exponential power spectral density. This figure shows the free body diagram for the quarter car model, the sprung mass as a body and a sprung mass for the tires, and this is question for quarter car model. The last one is suspension and linkage system. The suspension of modern vehicle has to satisfy several specifications which can be in conflict between them because of the different operating conditions like load, unload, acceleration, braking, lever, and even load, straight running, and cornering. The suspension system allows the roll and pitch motion of the vehicle chassis, while the yaw motion is indispensable of turning. And then suspension can be with rigid axle, semi-rigid axle, and independent wheels. Vehicle suspension can be with rigid axle, semi-rigid axle, and independent wheels, in which the relative motion of each wheel carry with respect to the vehicle chassis is independent.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azudin. Today I'll be presenting on chapter 3 methodology. For method in this experiment, in the project we have obstacle, vehicle, mathematical model, simulation model, experiment setup, and sensor location. For obstacle, we have work length with the length of 1.8 meter, width of 0.40 meter, and the height of 0.075. The obstacle was placed in the runway at unit tech outward runway. So for the vehicle used in this project is Motor Saga FLX 1.3 liter. The mathematical model, we have sprung mesh, unsprung mesh, and the MS represent the sprung mesh, LU represent unsprung mesh, ZS represent the vehicle body motion, which is the upper from the shock tower, ZU, which is the wheel body motion, the wheel itself, and ZR, road velocity, represent the bounce and obstacle. KS and KT represent the suspension and tire spring rate. CS represent the suspension and rim coefficient. So the component used in this project, the main component is Arduino Uno, accelerometer sensor, 2 unit breadboard wire, main jumper wire, breadboard, accelerometer wire, which is VCC, ground and Z up, the hot glue gun, and wire solder. So this is the circuit setup for project. We have MATLAB simulating software connected with the Arduino Uno, and the Arduino Uno connected to the breadboard that have a connection to the accelerometer of sprung mesh, the top of the shock tower. The unsprung mesh at the lower arm of the vehicle. So the sensor location, the sprung mesh on the top of the shock tower, front right, and the unsprung mesh at the lower arm, the left lower arm of the vehicle. So the experiment setup suggest in this video.
Assalamualaikum. My name is Nikmat Moshe. For simulation study of this vehicle motion project, it is used by MATLAB software, which is X1 is Sprung, X2 is unsprung mesh. So from the simulation, the data of displacement, acceleration, and velocity can be obtained, which is have used the parameter of speed vehicle at 10 km per hour, 15 km per hour, and 20 km per hour. Hence, the displacement is chosen for comparison to the experimental result. So based on the simulation result, the sprung and unsprung mesh of displacement at 10 km per hour has the highest and the lowest amplitude of graph compared to speed at 15 and 20 km per hour. Next, for experimental result, the accelerometer sensor is attached at the damper or shock absorber, which is it represent as a sprung mass, while on the lower arm sensor attached is represent as the unsprung mass. So next, based on the graph, for sprung and unsprung mass of G-force at 20 km per hour has the highest amplitude if compared to 10 km per hour and 15 km per hour. Based on the graph result, the car have passing through the bump is start at 30 seconds for 10 km per hour of vehicle speed. Meanwhile, at 15 seconds is for 15 km per hour and 10 seconds is for 20 km per hour. And then this is because the different acceleration of vehicle at initial start to run the experiment. But when the car is approaching the bump, the vehicle speed is maintained as the parameter that has been set before the car hit the bump. So the data of the experiment can be obtained accurately. In conclusion, the highest amplitude of G-force is integrated by highest velocity of the vehicle when vehicle hit the bump or passing through the bump. Hence, the best speed for passing through the bump is 10 km per hour, which is to maintain the ride comfort and the vehicle performance. So that's all. Thank you.